In the previous video, we discussed the difference between a nucleophile and a base, and how to classify strong bases and weak bases, strong nucleophiles and weak nucleophiles. And we saw there are 4 categories, and we discussed why each of these molecules are in each of these categories. So in this exercise, all we're doing is taking that knowledge, and we're going to apply it. What if this was a reagent? What type of a reagent would it be? What possible adventures can these molecules go on? So it says, identify whether each of the following reagents would be a strong nucleophile or a weak nucleophile. That's what we have in this column here. And also indicate whether it would be a strong base or a weak base, and that's what we have here. So we want to know which of these 4 categories each of these falls into. All right, well, let's start with A. We have an OH, and it's bonded to a carbon chain. Well, that is an alcohol. Remember that R is any carbon chain. So really, if you were trying to think of it separately, you would have that R here is this ethyl group. So what we're dealing with is a weak base and a weak nucleophile. So when we're trying to think of what type of reactions we can do with that, we need to consider what its potential is. It's a weak base and a weak nucleophile. What type of reactions will that favor? With B, we have sulfur. Sulfur, we talked about, big atom there. We have sulfur with an H bonded to an R. That R, again, is that R, and this whole molecule is RSH. That is a weak base, strong nucleophile. Now you can kind of see that if elimination and substitution were competing, and this molecule would do better with substitution because it's a strong nucleophile, but a weak base. And this next one, we have an R group, some carbon chain, and it's bonded to O-. Well, that's this right here. And in fact, this is ethoxide. Right? That R is the carbon chain, and then the O, that O has a full negative charge. You know that because it's bonded to a sodium, which is a metal, and gives its electrons away. And so this is a strong base, strong nucleophile. In this next one, we have a bromide ion, and bromide, like all the halogens, is a weak base and a strong nucleophile. And as we talked about in the previous video, all these sodiums are just counterions so that the reagent doesn't explode when you handle it in the laboratory. They're there to stabilize it. But this is a weak base, strong nucleophile. Next, we have lithium hydroxide, and you can see that the lithium there is not really important. It's a metal, so it's going to give its electrons away, and what we really have is OH-, and that is a strong base and a strong nucleophile. For methanol, this next molecule here, we have an OH bonded to an R group. Now remember that methyl group is an R group, and so really we're dealing with ROH. Well, that is a weak base and a weak nucleophile. Finally, in this last part, we have sodium methoxide. We have that O with an R group. Well, that's actually right here, that exact molecule. But O with an R group, that's in the same category these are strong bases, strong nucleophiles. So this is a strong base and a strong nucleophile. So in this video, we just went through a quick exercise of how you may see what we discussed at length and in detail in the previous video. These are how these reagents may show up in reactions. Now you can see these molecules and instantly think of their potential. Right? When you see people, sometimes you see what they could become, and when you see these molecules now, you want to start seeing what they could become, and you can classify their probable behavior using this table. Now, if you just skip to this video, this may look like just a bunch of information, and it may look like a memorization game. But if it's like that, I strongly encourage you to go to the previous video of this, where we discuss the concept behind these, the pattern behind these, that will allow you to first memorize it more easily, but second, give meaning to it and understand it rather than just have it in your memory. So we're going to use this in future videos, and right now we've just built up the skill of recognizing different types of bases and nucleophiles.